All right, so today we're going to analyze those geometric sequences a little more. We're going to look at those sequences, and if I'm not given the first term or if I'm not given the common difference, how do I go about doing those? So let's just refresh real quick on the geometric sequence itself. Remember, if I'm looking to write my general formula, I'd have a sub n would equal my first term, a sub 1, times my rate to the n minus 1 power. So we're going to refer to that sequence or formula a lot, so you might want to make sure you have it. And also for your own sake, if you want to keep the r in parentheses, especially if it's negative, probably save you a little bit of grief with those positive and negative signs. So on our first two things, we have been given a term of the geometric sequence and a common difference. So what we're going to need to do is, in order to write the sequence, we have to have our first term. So we're going to go out and we're going to find that by using our formula. So I'm going to plug this information into that formula, and we're going to solve for a sub 1. So my a sub n, my term value is actually 12, equals a sub 1 times my ratio of 2 to the n minus 1. So in this case, we're actually going to have 4 minus 1 up here. And then we're just going to solve for my problem. So I'm going to have 12 equals a sub 1. And this would be 2 to the third power, because 4 minus 1 is 3. So 2 to the third power, 2 times 2 is 4, times 2 is 8. And then I'm just going to divide by 8. And 12 divided by 8 would just simplify down to 3 over 2, or 1.5, right? So my first term now is 3 over 2. So I'm going to write my general formula for that. So I'm going to have a sub n equals my first term of 3 over 2 times 2, because that's my ratio, to the n minus 1 power. All right? Now, I can find the first 6 terms of my sequence here by doing a couple different ways. I could start with my first term of 3 over 2, and then I could just multiply by 2, because that's what that ratio does. So if I was to start with 3 halves and I multiply it by 2, I would get 3. If I multiply that by 2, I get 6, 12, 24, 28, or 48. Okay? If I don't like working that, I can plug each one of their term values in here. So I could have taken, I could have plugged 1 in for my n and then worked it out, and plugged 2 in for my n and worked it out, just like you did earlier in the unit. Okay? So let's write out some steps for those before we try another one. So the first thing we're going to do when we work this is we are going to use the general term to find a. To find a sub 1. Sorry, I kind of left that in the middle. To find my first term of my a sub 1. The second thing I'm going to do then is write the rule for the nth term. And then I'm going to use the rule to create my sequence. All right. So let's go ahead and try number 2 then. So this time we are given that our fifth term is 32 and my ratio is 2/3. So that means, remember, in a geometric sequence, I'm multiplying everything, the first term, by 2/3 and go from there. All right, so let's plug this into our formula that we're going to use, and I would have 32 would equal a sub n times 2/3. And remember that was the fifth term, so this is 5 minus 1 up here. So if I have 32 equals a sub n, 2/3 to the fourth power is 16/81. And I would try to refrain from using decimals if I can, just because they'll give you a more exact answer. But then I'm going to multiply this whole side by 81/16 so I can get rid of that fraction. So what I do to one side I have to do to the other. And then over here, 81/16 times 32, I'm going to come up with 162, and you can do all that on your calculator. Over here, these two cancel out, and I get a sub 1. So my first term is going to be 162. So let's plug the information we have in there. We know our first term. We know our ratio is 2/3. Let's plug that into our general equation. So a sub n would equal 162 times the ratio of 2/3 to the n minus 1. That is our sequence of the nth, or the rule for the nth term. Now we just need to write the first 6 terms. So I know my first term is 162. If I take 2/3 of that, I'm going to get 108. Or I could have plugged 2 in for my n. Right here, I could have put second term in here and then worked it out. The next one, 2/3 of 108 would be 72. Times 2/3 would be 48. Times 2/3 would be 32. Times 2/3 would be 21 1/3. All right. Okay. Well, let's see what happens then if I give you 2 points. Okay. So now I'm not going to give you the difference or your common ratio. I'm going to give you 2 points. And when we do this, we're going to have to find, like in the arithmetic one, you had to find like your difference. So we have to find our ratio. And sorry, I got a phone call, so I'm going to just pick up from where I was at. So wherever you do your ratio, that was a number times itself. So we're going to deal with like squares and cubes and things like that. So I'm going to show you how to find that. And if I'm looking for my ratio, I'm going to find that. I'm going to do my ratio minus my term numbers. So this is going to be 5 minus 2. That looks really bad. Let me erase that so you can really see it. So r is going to equal r to the 5 minus 2 power would equal my largest sequence number over my smaller one. So I should say the fifth term over the second term number. So I have to figure out how much of a difference there is but for each ratio. So this would be r to the third power. Negative 768 divided by 12 is negative 64. And then to undo that cube, I have to take the cubed root of that. So what number times itself 3 times gives me negative 64? And that ratio is negative 4. All right, so once I have that ratio, I'm going to choose a term. I'm going to choose one of these. So I'm going to choose 2 and 12, and then I'm going to find my a sub 1. So I'm going to plug it back into our general formula of a sub 1 times my ratio to the n minus 1 power. Okay. So I'm going to do 12 equals a sub 1. And I guess you could have, since this is a sub 2, I could have just divided by 4, and this answer should come out to be negative 3, just because I need to go down by 1. But let's go ahead and practice this. So my ratio is negative 4, and this would be 2 minus 1, since that's my n. So I have negative 12 equals a sub 1 to the negative 4 to the first power. I'm going to divide both sides by negative 4. And negative 3 would equal my a sub 1. So my general term here, since I have these two pieces of information, would be a sub n would equal negative 3 times negative 4 to the n minus 1. All right, so let's go ahead and write a couple steps for those. And I'm just going to kind of, I didn't really know how to write this, so I just wrote find the ratio using the examples we gave. Follow the examples if you need to, okay? Then you're going to use the general rule. To find A1, A sub 1, or your first term. And then once you do that, you're going to write your nth term rule. Write the rule for the nth term. All right, so let's go ahead and try number 4. All right, so this time I've got two, they're giving me 2 points. My third term is 20, and my sixth term is negative 160. So I know that there's going to be, the ratio has been multiplied by itself 3 times. So let's find that r. So I'm going to say r to the 6 minus 3 would equal 160 over 20. So we can simplify that. R to the third power would equal negative 8. And then to get r by itself, we're going to take the cubed root of that. And r would equal negative 2. So now choose one of your terms that you have, and you're going to plug it into your formula. So I have 20. I don't know my a sub 1. That's what I'm looking for. So I have negative 2 to the, that's the third, so it'd be 3 minus 1. And we're going to work and solve for a sub 1. So 20 would equal a sub 1, negative 2 squared, so this ends up being 4. So I'm going to divide by 4. And a sub 1 would equal 5. All right, then let's plug that into our general formula given that. So a sub n would equal 5 times negative 2 to the n minus 1 power. And then that would be my general sequence. All right, let's look at our last two problems. First one, again, you're going to look at this and realize by looking at it that, hey, this is an exponential growth, which is what happens geometrically. That's why we have a ratio instead of a difference. And I also notice I already have my first term, which that's a plus. So I know that a sub 1 equals 5. So now I just need to kind of find my ratio so I can plug it into my formula of a sub 1 times my rate times to the n minus 1 power. So let's go ahead and find, let's go ahead and just choose, I'm going to choose a different point. I'm going to choose 2 and 15. So I'm going to do 15 equals a sub 1. And we're actually going to find, well, I can plug in, let's actually find my ratio this way. We know my a sub 1 is actually 5, so I can actually work to find my rate, or my ratio, my 15, I'm talking about the second term, so it'd be 2 minus 1. So I'm going to have 15 equals 5 times r. I'm going to divide by 5, And the piece I didn't have this time was my ratio, which was 3. Okay, so now that I have my ratio and I have my first term, I can write my equation, I can write my general rule. So my a sub n would equal 5 times 3 to the n minus 1. So as long as you're given 2 points or a point, you're going to fill it in and find the things you don't know. Okay, so same thing here. I don't have my first term, but I can look at this and say, hey, you know what? This is being multiplied by -2, right? So sometimes it's easier to find my ratios doing this. So I'm going to say, okay, my ratio is -2. Could you figure out what your first term is here? Because I divide, right? So wouldn't this be 6? So now that I know my first term, my a sub 1 then is 6. And I can do all that by just looking at my chart. I can start working my problem. I don't even have to do all those steps. Or you can follow the steps, pick 2 points, find your ratio, kind of go from there. But this would be a sub n would equal 6 times -2 to the n minus 1 power. All right, hopefully this one's a little bit easier. Keep up the good work. I will talk to you later. Bye-bye.